Hello, Mr. Witherow here. Today we're going to talk about systems of inequalities. Lately we've been talking about systems of equalities. So two lines, that are equal. So today we're going to get back into this whole thing with the less than or greater than, less than or equal to, greater than or equal to. We've got to remember a couple things here. Remember, when it's just like this, we have dashed lines. When we have it or greater or equal than or equal to, then we have a solid line. All right, so remember these two things because those are important to get full credit on everything. Remember that we do a test point, 0, 0. If the line does not go through the origin, then test the origin or test any point that you want. I don't care. All right, now, if it is a true statement, then you have to include that point, whichever point you use. Now I use 0, 0 in the shaded area. There's no, hardcore, hey, if it's true, always shade down or always shade up. No, that doesn't mean anything. It just means that if this point is true, that means it's part of the solution. So shade it. If this point is false, that means it's not part of the solution, so exclude it. That's what it means. All right, also the biggest other thing is don't forget to flip the direction of the inequality. So when you are solving for y and you have to multiply or divide by a negative number, you have to flip the direction. All right, so systems means two inequalities with two variables. We graph them, we shade them, and then the overlapping shaded part is the solution set. That's your answer. All right, so let's get started. First one here, we have y is less than negative 5x plus 6. So again, it's the whole, this is your y intercept, and this is your slope. So 6, 1, 2, 3, 4, 5, 6. My slope is negative 5 over 1, so down 5, 1, 2, 3, 4, 5, back or forward 1, 1, 2, 3, 4, 5, forward 1, 1, 2, 3, 4, 5, forward 1. And I'm going. All right, again, this is just less than, so this is our dashed line. So we have dashed here. So just do a couple of those. There we go. And then I'm gonna switch, and let's test, right? So we're gonna test 0, 0 to see which way we shade. So we're gonna have 0 is less than negative 5 times 0 plus 6. So 0 is less than 6. True or false? That is true. 0 is less than 6. So that means this point right here gets shaded. That's part of the solution set. So I'm going to shade this way. All right, cool. Now I'm going to get my orange marker here, and we're going to do this one. So then we have negative 1 is my y-intercept. So I'm here, and slope is 2 over 1. So up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, down 2, back 1, down 2, back 1, down 2, back 1. And since it is or equal to, we get to do the solid line. So we go through right here. Okay, so now we have to test 0, 0, right? So that means that it is, and I got a piece of tape here, so let's go down here. 0 is greater than or equal to 2 times 0 minus 1, which is 0 is greater than or equal to negative 1. That is true. So again, here is my 0, 0. So this is my solution set, or I'm shading this way. So you can now see where the overlapping part is, and that is right here. This is, you can't go past this line here, right? So all of this is my shading part, and I can't go down below this orange line. So this would be my shading part. Now please do not do this for me, right? Don't shade that extra part, but I just want to make sure you can see it. I'm okay with you just leaving it the way you shaded it. I get it. I get that you did it right. All right, so that's one way we can shade it. I'll show you a different way to shade it here in a second. That way that you can sort of kind of see it. All right. Okay, let's take a look at the second one down here. Now it says that 3x minus y is less than 6 and 3x minus y is greater than negative 2. Now I've already done all the work for us, right? So we went ahead and got y by itself. Now this is where we have negative y is less than negative 3x plus 6, and we have to divide by negative 1. Notice how I flipped the sign. I did this on both of them. So I flip that sign. My test point is 0, 0, so I put it in here, and I get both of these are true. All right, so follow along here if you need to. Pause it and look to see how I solve for y, but let's just get right into graphing. All right, so if I have my graph here, and here's my inequality, so negative 6, 1, 2, 3, 4, 5, 6. And my slope is up 3 over 1, positive direction, or down 3 back 1. Okay, and then this is just greater than, so it's a dashed line. So I'm just gonna put dashes in between here. There you go. All right, I'm not gonna shade anything yet. I'll show you reason why here, all right? So then the second one, the orange one, here is my equation right here, or my inequality. So I'm at 2, and my slope is again 3 over 1, so these are going to be parallel because they have the same slope, right? 1, 2, 3 over 1, 1, 2, 3 over 1, 1, 2, 3 back, 1, 2, 3 back, 1, 2, 3 back. There we go. And this again is also dashed. So again, if we just put it here, okay? All right, so now, I haven't shaded yet because I wanted to see what's going on here, so I can just minimize what I've shaded here. So since I got the orange one in my hand, let's do this one. It is true. My test point is 0, 0. It is true. So that means that it's on the other side of this. This point right here is part of the solution. So I'm in here. I would shade here. Now notice I don't go all the way through this line. That's my boundary, right? So I can't go past that. And then my blue here is also true, right? So again, this point right here is true. So that means I would shade here. So in this case, right? In this case, then it's the area that's inside the parallel lines. So again, you can see the difference of how I shaded it. This one up here, I just shaded everything. I shaded after I graphed it. This one or after I graphed the line. This one I waited until I graphed both of them, and then shaded only the area that they overlap. So that would be my solution set. All right, and then the last one is down here at the bottom, and we have x is less than negative 4, all right? So x is less than negative 4, so that's this. I'm gonna use this one over here. So at negative 4, 1, 2, 3, 4. So here it is, since it's less than, it's a dashed line at negative 4. All right, so that's what that means. It's a vertical line. And then I have my blue line is right here. Its y-intercept is negative 1. Slope is negative 3 over 2. So if I went down 3, and then I'd go forward 2, down 3, forward 2, or I can go up 3, 1, 2, 3, back 2, 1, 2, 3, back 2, 1, 2, 3, back 2. All right, and this one actually is a solid line. So I come in here and give me my solid line. All right, let's look at what we need to do to graph here. All right, so this says my test point was 0, 0. It's false. So that means that this point right here doesn't get included. All right, so that means that I would be shading this way. All right, so I'll wait to see what this yellow line or the orange line is. The orange line says that it is less than negative 4. So what's less than negative 4? Well, negative 5, negative 6. So all of this area is less than negative 4. All right, so again, if we go back to this one, if this was false, That means none of this is in part of it. It's just right here. All right? So that's what we're looking for here. We have that area right here. This is what's looking at. Okay? Cool. Good luck. Keep having fun with math.